Hello, everyone. How are you guys doing today? Uh, so, any question before we start? Any comment, concern, complaint? Nothing? Okay, then. Since we have nothing to talk about, we are going straight to our section 1.3. 1.3, right? Yeah, 1.3. Do you remember doing this in our last class? Do you remember what's the step to start finding regression line? So today I'm going to show you one manually and one using calculator. Do you guys have a calculator with you today? No? Yes, no? Okay. I don't have the physical 89, TA89. So I'll try to show it on Google if it works. If it doesn't work, then you can just Google it by yourself. How to find regression line on your calculator. Or if you have TA84, I can show you if you want me to. But I don't have the physical one. Come on. So one of these questions definitely will be in the in-class exam and also in the final exam. Usually in the final exam, they put this question in calculator portion. Okay. It says a company wants to understand the relationship between the amount of money they spend on ad and the total sale they receive after spending the money on sale. So on ad. So suppose this is what we have. Hello. If they spend $1,000 on their ad, then they receive $4,000 money on sale. If they spend $2,000 on ad, they get $8,000 sale. So the more money they spend on their ads, the more sale they get. So they're asking, well, use linear regression and find out when estimate the sale after spending 25,000. So if you spend $25,000, how much sale you're going to have? Did you understand the question? Okay. So they're already mentioning that we have to use linear regression. That means y equals mx plus b. In our case, it's y equals ax plus b. A and B, we have to find using formulas. And based on the formula, we are going to make our table. So we have one column for x, which is add, 1D. Add. We have another column for y, which is the sales. Right? Do you remember completing this table before? So we have 1, 2, 3, 4. That means what is our n? Do you remember what n is? It's how many pairs you have. So how many pairs of x and y you have? 1, 2, 3, 4. You have 4 pairs. So n is 4 here. Now for y we have 4, 8, 10, 15. So what do we need? What should be our next column? X times Y. And then we need one more column, right? Oh, no problem. Yeah, we do. X squared. Because we need sum of the xy, sum of the y squared, sum of the x, sum of the y. I should write smaller so that I have enough space for my sum. 3, 4, 10, 15. Okay, so let's find sum of the x. How much is the sum of the x? 10. Then we need sum of the y's. 37? Not 7, right? Oh, 7? Okay, 25 and then 29. Yep. 37. So now let's find xy. Let me change the color. The first xy. 4. The next one. 16. Next one. 30. And the last one. 60. So what's the sum? Hmm? 110. Then you go to x squared. What's the first x squared? 1. Next one. Next. And the last. So we need the sum now. 30. So you have all the information we needed. Now all you have to do is substitute. What is our n? 4. It says with the n, multiply sum of xy. So how much is our sum of xy? 110. Now subtract the product of sum of x and sum of y. So what is our sum of x? 10. And sum of y? 37. Now whatever we have, we are going to divide by, again, n. But this time, multiply our n by sum of x squared. So how much is the sum of x squared? 30. And now subtract the sum of x, that thing squared. So sum of x, which is 10 squared. No, you have to remember this. And then if it's in the non-calculator portion, you have to solve this using non-calculator, it's using your brain. And if it's in the calculator portion, we don't even have to do any of this. You just punch all the information in the calculator and it will give you the final answer. So since we are not allowed to use calculator, we can modify using our brain. What is 4 times 110? 440. 37 times 10. 370. 4 times 30. 120. And 10 squared. 100. So these numbers are easy. So in the exam, you're going to see numbers like this for the non-calculator portion. Now 440 minus 370. 70. And 120 minus 100. 20. So we get 7/2. right? 7/2 or 3.5. And then we now need B. B needs sum of Y first. So what is sum of Y? 37. And we need to subtract 8 times. So let's see if here is 7/2. Does it make things easier? Yep. And now we need to multiply our A by sum of X. 10. Whole thing we divide by? What is N? 4. Now, one good thing about this one is that here we can actually cancel 2 and 10. We get 5. 2 goes to 10 5 times. So we don't need any calculator. We can do it manually using our brain. So multiply this. So 37 minus 7 times 5. 35 divided by 4, which is 2/4, which is 1/2 or 0.5. So the line, the regression line we are looking for says regression equation is y equals ax plus b. In other words, y equals 7/2 x plus 1/2, or y equals 3.5x plus 0.5. But we cannot stop because they want us to know when we have $25,000 spent on ad, how much sale we are going to get. So what is this 25, X or the Y? X, because $25,000 you're spending. When you spend, in this scenario, it's X. So they gave us X is 25. So Y equals to 7/2 times 25 plus 1/2. Since you have to do it manually, that means you have to multiply this. Or we can do 7 times half of 25 to make our life easier, plus 0.5. What is half of 25? 12.5 times 7 plus 0.5. Which one is easier? Multiply 12 times 7, 25 times 7 divided by 2, or 12.7 times 12.5 times 7. Whatever that is, you have to do it manually. So 12.5 times 7. 7 times 5 is 35. 5 goes on the bottom. 3 goes on the top as an addition. 7 times 2, then you put a decimal. 7 times 2 is 14, plus the 3 is 17. 7 goes bottom, 1 goes on the top as an addition. 7 times 1 is 7, plus 1 is 8. So we have 87.5 plus the 0.5. What's the answer? This should be easy, right? 87.5 plus another 0.5. How? 88. So if you spend $25,000, you're going to get $88,000 sale, which is a great thing. Any question?
What did you get?
How many data set is given to you? 1, 2, 3, 4. Any other question? So I'm going to show you later how to do this in the calculator. But before that, we need to learn one more thing, correlation coefficient. The correlation coefficient we represent that by small r, and it tells us what type of relationship we have. Correlation, correlation. It's like correlation. So if we have any relation between our x and y, if we do, what type of relation? Positive or negative? And how strong the relationship is. Is it weak or very strong or medium? We get all this information just by observing R, the correlation coefficient. To find the correlation coefficient, there are several formulas. 1, 2. My favorite one is this one because we can just use our table and find all the information. If you observe, the numerator of this coefficient is same as the numerator of A. And denominator is almost same. So if you ignore this, only the top and the first part is A, but you do the same thing for Y and then take the square root. So it's A plus more, then you get the correlation coefficient. Now when you have correlation coefficient, we get a number that lies only between -1 to +1. If you get bigger than +1 or smaller than -1, that means you did something wrong in your calculation. So check your work. R cannot be bigger than 1 or smaller than -1. All the numbers have to be fraction, decimal, that is smaller than 1 or -1. Sorry, smaller than 1, bigger than -1. Now, how do you know? No. In the exam, there are two parts. The first part doesn't have calculator, and the second part has a calculator. In the final exam, the first part has 22 questions, non-calculator, and the second part, calculator question, has 8 of them. And total, we have 30 questions, 26 multiple choice, sorry, 24 multiple choice, and 6 non-multiple choice. But even if you have multiple choice, you must show the correct work to get the credit. So, for in-class exam, I'm not going to ask you to find the correlation by hand, but I'll ask you to find the equation by hand. So you have to at least remember the equation for A and B. Memorize the equation, A and B. And I'm going to give you something smaller like the one we just did, the example. But in the final exam, most of the time, not always, they give this question in the calculator part. So if you use a calculator, you can able to find it easily. End of this month, I assume. I'll let you know, like once we cover few sections, then we are ready for the exam. So I think our syllabus tells us after how many sections we want our exams, right? If I'm not wrong. I'll check that later, but I'll let you know. Okay, Nate. So if you have a correlation, so it's like number line. It lies only from -1 to 1. And if you're closer to 1 or closer to -1, that means you have a very strong correlation. If you're near 0, then it means you have very weak correlation. If you have +1, it means you have a positive correlation. It means when X is going up, Y is going up. If R is negative number, then you have a negative correlation. It means when X is going up, Y is going down. So negative correlation, negative sign means you have negative correlation. When one is increasing, other is decreasing. Positive number for R means you have positive correlation. When one variable is increasing, the other variable is also increasing. And when you have near zero, you have a correlation, it's very weak. If you have negative number, you have negative weak correlation. If you have positive number, you have positive weak correlation. And if it's exactly zero, there is no linear correlation. Okay? You may have other types of correlation, like upside down correlation or exponential correlation. Having R equals 0 means there is no linear correlation. Okay? Clear? So let's do some examples. We have a bunch of plotted data on XY plane. So it's a scatter plot. Based on the scatter plots, what do you think the correlation between the two variables? Variable X and variable Y. By observing these data sets, what is your idea? First of all, what type of correlation you see? A positive or a negative? Positive. You can draw a line either here or you can draw a line here. There are two choices. So positive, that means A is wrong, B is wrong. So we have two choices, C, D, or E. So what type of correlation you have? Strong or weak? Looks strong, right? If you ignore that, observe this data, this best line of the best fields, we have a bunch of points closer together. So it's a strong correlation. And if you ignore that, observe the rest, it looks like they have a strong correlation. They're closer to one another, right? So it's kind of strong. So is it 0.05? 0.05 is close to 0, means weak. So it's definitely not this. This represents weak. And now we have 0.5 or 0.9. Which one makes sense? 0.5 is here, 0.9 is here. So we're observing a data set. Which one makes sense? 0.5 or 0.9? 0.5 is in the middle. You just told me strong, right? Because look at this bunch of data sets. They are closer to one another, very close to one another. So there is strong relation here. And if you look at these, all of these, they are close to one another. So it doesn't matter which line you draw, in both lines, they have a strong relation. So it should be actually 0.98. They're strong. This is a little bit weaker, but this is weakest. So strong, weaker, weakest, definitely not the weakest one. And weaker, we can say that, but by observing them, it looks like they're strong. So best one is 0.98. Question? Think about this one. Definitely it's not negative and not negative because it's an increasing line, so it's positive slope. And how about C? Exactly. We cannot have more than one, so we have to disregard C. It's 1.3, not possible. So we have two candidates, either B or E. So which type of correlation we have? Very weak or strong? This one is 0.08, which is closer to 0. It's 0.08, not 0.8, it's 0.08. So this is closer to 0 and this is closer to 1. Which one makes sense? Closer to 1. Because It's not so strong, it looks like, but it's not very weak either. All of these, they're closer to one another. And we have small gap here, but all of these are also closer to one another. So it's not very weak. It should be moderate, I would say, but they don't have any option for moderate. They have high. Question? No? So I'm going to give a few of these in the exam just for you to have fun. Okay, now one example where we are going to find the correlation coefficient and the regression line. So it says we have number of years and then how much we get for the revenue. It is using the linear regression, estimate the revenue in year 10. So what is given here? What is 10? The X value or the Y value? X. So year is X, revenue is Y. They gave us, this is 10. We need to find out what is Y. That's one. And the other thing is find the correlation coefficient, means R, and then use it to determine the correlation type, means positive or negative, and the strength, how strong they are. I mean, yeah. So, any questions so far? So let me try doing it in the calculator. Can you guys write down these numbers? You did? Okay, thank you. So here I wrote down the direction. You can't even see that, but I'll read it out. So let me take this. Come on. Okay. Also, I need this. So it says first plot the points inside, insert the points in your calculator. So you press F. I can't even see F. Press F and then choose data matrix. Okay, so F is here. And then we have to go to, can you see the screen? Is it a little bit clear at least? The calculator? So you scroll down to data matrix editor, enter, and then we have to make a new one. New. And then we are going to put X and Y. Man. Data, math, variable. I can't even see anything here. I have no idea. Type, center, okay. Type, enter, okay. And escape, cancel. It would be easier actually if we use a physical calculator. Do any of you have physical calculator? No. Variable flushes used. This means X being used, a variable somewhere, blah, 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 blah. X, screen X for the variable, enter X for the variable. So enter X for the variable, enter twice. And then we have for C1, 1, 2, 3, 4. Oh no, our data point is different. Sorry, my bad. Oh yeah. What is our data point? Can you tell me the X numbers? The one you copied. 147. Thank you. 1, 4, 7. Anything else? Only 3, right? Okay. So you go to Y. it go up. And can you tell me the Y numbers? 3, 6, 11. So we inserted our data and then press F5. So F5 is here. And now I'm going to move this. You choose linear regression. Man, I can't even see anything. Hit the right arrow to see linear regression. So you go down to linear regression, number 5, hit enter, and enter another time. Oh no. Cancel. I didn't specify my thing. Escape for cancel. Why is escape here? Why it says tar X? So this is X, enter. No. How do I go here? For X, we have to enter linear regression. Why it says X type C1 alpha hidden? Then, so you have to click down here actually, and then C1. So alpha C, no, it's bracket clear. Diamond C1. I don't even see what they're writing here. Invalid. Okay. To enter, press, if it says X type C1, use the alpha key then. Alpha key. Yeah. Mine is so hard to see here. Alpha. Check the very bottom of the screen and it says the little letter I. Hitting alpha will turn on and off. You need to have this A to choose the letter and turn the number, then C2. Okay, alpha, we have A. So probably I have to deselect alpha. No. One. Okay. Deselect C2. And I have to deselect C2. And I'm going to take, I knew it. C2, I have to clear. So diamond, I see C here. But then I have to click alpha C. Okay, I think now it will take it. And then enter. Oh man, my eyes are hurting so badly. So it gave us the results. Write down. A is 1.33. B is also 1.33. Correlation, when it says can you even see now, right? The first one is A, let's B, there is CORM is correlation coefficient. That thing is 0.9897. Ah. So we write down our equation. Y equals ax plus b. It means y equal, what is a? 1.33x. What is b? 1.33. So they want us to replace x with 10. So y equals 1.33 times 10 plus 1.33. Whatever you have, that's your answer. And for r, it says r equals 0.9897. So correlation coefficient B is that, and it says determine the correlation type. So what type of correlation you have, positive or negative? Positive. How strong? Strong, moderate, or weak? Strong. Positive, strong correlation. Ah, that's all you have to do. First, you enter your data set in the calculator, then you go and tell calculator to calculate the linear regression model for you. It gives you all the results, including your R. So you put everything in the equation, and then you're done. So that's why using calculator is much easier in our real life. But in the exam, I'm going to give one question in the non-calculator with smaller numbers. So it makes things, it will be easier for you to calculate. But the downside is that you have to remember these two formula. And then in the final exam, you're going to use calculator to calculate this. I understand. So I would suggest go to YouTube and ask how to find linear regression on your calculator. Like if you're TA89, write how to find linear regression on TA89. If you're TA84, write how to find linear regression on TA84. And then it will give you much clearer video. With this, we are done with 1.3. Any question? So homework for next Tuesday, which is 9/9/25. You have section 1.1, 1.2, and 1.3. 3 homeworks due by Tuesday midnight next week on my MATLAB. If you didn't do 1.1 yet, but I thought I said 1.1 due date was last Tuesday midnight, right? But then some people told me that they didn't get the access yet. So I'm going to open it again, and then all 3 homework due date will be next week, Tuesday midnight. Okay? Questions? Comments? Okay. Take 2 minutes to be a human being. Let me take your attendance. And then you will start 1.4. You can talk with your neighbor, stretch, refresh your head. Today is what, 5? 1, 2, 3, 4, 5. So 9. Dominica, Salahuddin, Arsla, Maxine, Zoe, Claire, Jolene, Jalin, Jolene, right? Prince, Hayden, Ellen. Ellen, right? Not Ellen. Ellen. Asir. Skyly. Alice. Jasmina. Alexandra. Jennifer. Jessie. Johnny. Afiz. Tarin. Pedro. Erica. MD. What is your middle name? Jawan. Jawad. For some reason, it gave me only MD, so let me write it down. Jawad. Ruby. Siam. Dimitri. Shiki. Siki, right? Siki. Sorry, my bad. Amar. Or Amir. 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 And William. William Zhang. Okay, so who is missing? Salahuddin. Salahuddin Noman. No. That's it? Ooh, only one accent. Wonderful. Okay, are you guys ready to learn a new thing? Even if you're not ready, you have to learn. So let's go to section 1.4. 1.4 is a big section, so probably it will take 2 or 3 classes. Now in 1.4, we are going to learn about functions, and from here there will be at least 4 questions in the final exam. I highlighted the difference questions, domain question, composition question, and finding a composition question, evaluating. Okay, so this section is very important. You're going to have a few questions from here. So first we start with function. When we start with function, the first thing we have to think about is a relation. Relation is like relationship. When we have any 2x and y, any pairs of x and y, we have a relationship between them. So a relation is a bunch of ordered sets, just x and y next to one another. In that set of relation, all the x values, they represent the domain or the input or the independent variable. And on the y values, they represent the range or output or their dependent variable. Now, when we have a relation, we have to see which of these relation gives us function. Why do you care about function? Because function has some characteristic which is very helpful for us to work with them. So that's why we want to figure out which relation represents a function. There is a formal definition and there is a shortcut. The formal definition says a function f is a relation that assigns a single value in the range to each value in the domain. Basically, they are saying for every one x, you have only one y. This is what it means. In the range, you have one number for every x in the domain. Now, if you can't remember this thing, no problem. All you have to do is remember it cannot have same x value more than once. For one x, you have to have one y. For one x, if you have two y's, it's not a function. So we cannot have same x more than once. Example, let's start with something basic. Let me write this down. We have a relation 1, 6, 2, 6, 3, 8, and 4, 9. So they have a relationship between them. We want to see if this relation gives us a function. Before that, we need to know our domain, because domain tells us whether we have a function or not. What is domain? Domain represent what? X or Y? Which one? X. So what X values you see here? 1, 2, 3, 4. Do you see the same X value more than once? No. So do we have a function or not? Yes. All of these relations, they represent a function. And they said, well, also tell me the range. So what is range? Y. So what Y values you see? 6, 6, 8, 9. But my method said, don't waste your time writing the same thing twice. Instead, just give me 1, 6. So 6, 8, 9. We see that we have same Y value twice, but we don't care. Because in order to be a function, we cannot have same X value. However, later, I think we are going to learn about one-to-one function. In order to be one-to-one function, our Y also cannot be repeated. So this is a function, but not one-to-one function. Clear? Now the second example. What if we switch their position? 1, 6 becomes 6, 1, then 6, 2, then 8, 3, then 9, 4. Think about its domain, its range, and whether you have a function or not. Ready? So what's the domain we have for this one? 6, 6, then 8, 9. Oh, does it represent a function? Not a function. Because we see the same X value twice. So when you insert this on MyMathLab, you're going to write 6, 8, 9. But since we know we have same number twice, so we already know it's not a function. How about the Y? Sorry, how about the range? What's the range this time? 1, 2, 3, 4. Can we say it's a one-to-one function? No Y's are repeating, so is it a one-to-one function? Of course not, because it's not even a function. So Y may not be repeated, but when it fails to be a function, we don't care about the rest. So this is a function, but not one-to-one, because the Y value repeats. And here, Y value doesn't repeat, but X is telling us it's not even a function. So when it's not a function, it definitely cannot be one-to-one function. Okay? Question? Great. Now instead of having the points in front of you, they plotted the points for you. Let me make them darker for you so that you can see. This is 1 point, this is another, this is another, this is another. And here we have 1 point, 2 point, 3 point, and 4 points. So for A, what do you think? Is it a function or not a function? It's a function? Why do you think that? How do you know? If you observe all the x's, we have -4, -2, -1, and +1. We have 4 points, 4 x values, so it is a function. How about why not? Good observation. If you try to use vertical line test, that vertical line has 2 points from the same graph. This is one way of verifying. Another way of verifying is just observe your axis. This point has x value -2. Here we have the same one twice for these 2 points. This point has x1, also this point has x1. So we see 1 twice, and then we have a 2. Because we have the same x value twice, it cannot be a function. Question? So is this clear? Now they give you something like this. They are telling us we have a domain of these numbers and a range of these numbers. So which representation tells us about something, being about function. Do you know how to read this? How about A? Is it a function or not a function? Why not? Same x value?
Not same x value,
but in order to be a function, it cannot have the same x value. Alice, why? See, we have 4 x values, and each of them have their individual y values. Y can be repeated. You can see the same y twice, but x cannot have 2 of them. We see 4 once, it has a y value. We see 8 once, it has a y value. We see 12 only once, it has a y value. And we see 16 once, it is a y value. So all those x, they have their individual y values. Y values can be same, no problem. But if you look at the lines, 4 has 1 y. 8 has another y. 12 has another y. 16 has another y. So they all have their individual y's. So it is a function. To the next one. What do you observe in the next one? Why not? Exactly. 10 has 1 y value. So we have 1 line. 8 has 1 y value. It has 1 line. But for 9, how many y values it has? 1 twice. So if you want to write this down, we have 21 y, 8 1 y, 9 we have y1, 9 we have y2. We see 9 twice. And then we have -3. But since 1 9 has 2 y's, it cannot be a function. the not function. These are from your homework, so I'm helping you doing your homework. Question? Great. Now we have a next scenario. What if we give you the graphs? By observing the graphs, how can we determine whether these graphs are from a function or are not from a function? Vertical line test. So all you have to do is draw a vertical line and see how many intersections you have. If the graph has more than one intersection with the vertical line, it's not a function. So to be a function, you're allowed to have only one intersection with the vertical line. So the first one, is it a function?
No.
No. We see one intersection here, another intersection here. So it's not a function. So how about the next one? And the last one.
Yeah.
So it doesn't matter where you draw your vertical line, you see there is only one intersection. So this is yes, this is yes. 4 more. Any volunteer for A? Yes. Because you have one intersection. For B?
Yeah.
Yes. We can do the vertical line here, one intersection. Easy. C? It is because we have one intersection. The last one, tricky one.
It's not a function.
Why not?
Because x represents one x.
If you draw the vertical line, it's the same line, right? So you have so many intersection. No. So an increasing line is a function. A horizontal line is a function. But a vertical line is not a function. Okay? Can you guess what we're going to do next? We learn from points whether how do you know some points represent a function or not? Then we look at the plotted points and we found whether they're a function or not. Then you looked at that diagram and then you looked at the graph. So what is next? Say it again louder. We are still doing function. What we want to know next? Which type of things we want to know next about being a function or not? Equation. What if no graphs are given to you? No points are given to you? Then what do? You are given some equations, a bunch of equations. How do you know which of these equations represent a function or not? There are two things, formal method and shortcut method. The formal method says, in order to be a function, you can be able to solve for y. If you can't solve for y, then you have to observe for one x value, how many y's you have. If you have one y value, then it's a function. But if you have more than one y value, then it's not a function. So if you use a formal definition, that means you have to do math to solve for y. So that's why there's a shortcut I observed. If y has an odd power, then it is a function. We don't care about x at all. We only look at the y. If y has an odd power, it's a function. But if y has even power, or you don't see any y, that means it's not a function. Now my question is, what is odd? What numbers are odd? Still louder. 1, 3, 5, 7, those, right? And what numbers are even? 2, 4, 6, those. You all know this, right? Now let's do some example. The first one is y equals x squared. Is it a function or not a function? Y is a function? Why? It is a function, true. But why? Because y has invisible 1 power, which is odd. So y has odd powers. Y should say power. Y has odd power or odd degree. Since it has odd power or odd degree, so it's a function. Or if you know the graph, then you can do that vertical line testing. Y equals x squared. What's the shape of the graph? Do you know the shape of the graph? X squared? It's a parabola. So if you draw a vertical line test, is it a graph? So is it a function? Yes. So if you know the graph, you can just draw the graph and use vertical line test. But if you don't know the graph, the easy way is just look at the y. That's it. Now the next one. X equals 8. Why not? Good. No. No y. If you don't have a y, if the y is even, it's not a function. Or you can use the graph. Do you know what's the graph? How the graph looks like for x equals 8? It's a vertical line. When x is 8, you draw a vertical line. Is a vertical line a function? No. And now the last one. Volunteer for last one.
No.
Why not?
No.
Y has even power. So it's not a function. You see, we didn't do any math. Just by observing the y, we answered all the questions. So in order to do this, you have to memorize or remember the shortcuts. Okay, so now since we see the example of function and not function, now what is people don't know the rules? So how would they figure out whether they're working with a function or they're not working with a function? Okay, so in order for others to not to use their brain, we actually tell them indirectly that this is a function. Do you know how can you indicate that without saying any word? How can you tell others that the thing I'm giving you, the equation I'm giving you, is a function? Do you know what do we use for that? Instead of using y, we use function notation. So instead of saying y equals x squared, because people may not know what is x squared, is it a function or not a function? But if you tell them f of x equals x squared, they will know right away, oh, this is a function. How do they know? Because we didn't use y, we use f of x. It means this is a function of x. Okay? So this is called function notation. Instead of using y, use f of x. F of x represents the function notation. F of x and y, they're the exact same things. They're just two different versions of the same thing. When you see y, you have no idea is it a function or not. But when you see f of x, you automatically should know that this is a function. Question? Okay. So when you have a function, you need to know what's the y value if the x value is given. So you're evaluating function. All you have to do is replace all the x you see in your function by the number they give you, and then simplify with algebra. Example. They're telling us we have a function 10x squared plus 4x minus 1. So f of x is 10x squared plus 4x minus 1. They're asking find f of negative 2/5. That means every x you see in your function. So keep writing the entire thing, but don't write x. There will be no more x. All these x, come on. All these x will become negative 2/5. So step 1, replace all the x or substitute all the x with negative 2/5, and then using algebra, simplify them. So for this portion, do we multiply the 10 first, or do we apply the square first? Square, because of the PEMDAS. PEMDAS says do the exponent first before you go for multiplication. So we leave our 10 alone, and we work with negative 2/5 square. What is negative 2/5 square? Positive 4/25. So basically you're squaring everything. Negative square means negative times negative becomes positive. 2 square means 2 times 2, 4. 5 square means 5 times 5, 25. And now we can multiply. But we don't have to multiply because we can easily divide first. 10 and 25, they are divisible by what? 5. So 5 goes to 10 how many times? 2. So instead of 10, we write 2 there because we are canceling 10 by 5. So instead of writing 25, what do we write? 5. So instead of 10, we get 2. And instead of 25, we get 5. So now what is left on the numerator? 2 and 4, right? So what is 2 times 4? 8. And what is our denominator? 5. We have only one denominator, so it goes in the denominator. But we have 2 numerators, so multiply them. Now the next term. Can you cancel 4 and 5? That means we really have to multiply this time. We multiply only the numerators. What do we get? Negative 8/5. So bring it down. And then we have the lonely negative 1. We bring it down. What do you observe? Do you observe anything here? What do you observe? Positive 8/5 and negative 8/5, they cancel out. So we don't even have to do any fraction math. They cancel out automatically. So what is our final answer? Negative 1. So even though the fraction looks bad, but at the end, both of them cancel out. There is nothing to be afraid of. Any question? So we're going to do the same thing again, but instead of using a number, we are going to use a variable this time. So this is the scenario. We have a parabola. They are saying if this is x, that means we have something here, x plus h. So they're saying find what is f of x and what is f of x plus h, and then subtract them to see how much you have for the y differences. So what's the difference? We know the difference here is h. They are h unit apart. So how about the y's? For y's, how much difference we have? How much is this length here? From this y value to this y value. So this is what they're asking. But we are going to do the same thing. There's f of x is x squared plus 1. Find f of x plus h first. So instead of writing x squared plus 1, you're going to replace that by x plus h. So don't write x squared plus 1, write everything inside x plus h and then the square. Square means what? You're multiplying same thing what? How many times? Twice. So you cannot distribute x squared here. You have to multiply the base, same thing twice. This is what it means. Multiply the base twice. It's not x squared plus h squared, not. It's the FOILing. You have to use the FOILing method. Or if you know your special formula, then you can use the special formula. So if you do use FOILing, you're going to FOIL them out this way. But if you like a shortcut like me, how much you're going to get at the end? X squared then plus 2xh plus h squared. And you have your lonely one. So again, you cannot distribute to power. You have to FOIL them out. Once you FOIL them out, if you have anything to combine, you combine them. And if you don't have anything, just leave them alone. The second step says once you find f of x plus h, now subtract f of x from there. So what did we find for f of x plus h? This entire big thing, right? So x squared plus 2xh plus h squared plus 1. And now we are going to subtract f of x. What is f of x? X squared plus 1. But we are subtracting more than one element. So what do we need? Parentheses. Otherwise, it doesn't make sense. Anytime you subtract more than one thing, all the sign will change. So you have to put parentheses. We are putting parentheses because the sign will turn into a negative. So we have x squared plus 2xh plus h squared plus 1 minus x squared minus 1. So what do you see? X squared. 1, 1. So what is left? 2xh. My square looks like bird. So I should write 2 in this way. Okay, so you may wonder why we are doing all these things. Like, what's the point? Well, the main point behind doing this is the next topic, difference quotient. What I'm not going to do today, but I'm just going to give a heads up. In the difference quotient, we have to find the difference of the y values and divided by the difference in the x values. So basically, we need to find the slope. Another way of finding the slope is using difference quotient. You may wonder, why do we care about difference quotient? Well, we care about that because this is the definition of the derivative. When you take the limit of difference quotient, we are looking for the derivative. And derivative is what we need in many cases in our life. Okay? So goodbye. See you all tomorrow. Enjoy the rest of the day. If you want to start doing the homework, please start anytime.